Welcome, my name is Dr. Dan Wedding, and this is Dr. Wedding, PLC02. Ladder logic with the XIC, XIO, and OTE commands. Most people use ladder logic to write a programmable logic controller program. It is called ladder logic because the code looks like a ladder. The graphical representation of a ladder logic program is called a ladder logic diagram. The input commands are based on relays, and the output commands are based on an output coil. Not only does a ladder logic diagram look like a ladder, many of the terms used to describe it are also the same as a ladder. On the right and left, there are rails, and the rails are joined together with horizontal rungs, where each rung represents a control logic rule. These rules are evaluated from left to right. Depending upon your background, there are two ways to look at how ladder logic works. The first way is if you come from a digital logic background. You might think of the left rail as logical 1, and each command on the rung will perform a logical operation on the signal, similar to gate logic. The output will either be a 0 or a 1. Where a 0 will turn the output device off, and a 1 will turn the output on. If you come from a relay logic background or a circuits background, then you might think of the left rail as a positive voltage and the right rail as a negative voltage. And each command on the rung will act like a switch that will either conduct or block the voltage from reaching the output. If the voltage reaches the output device, it will turn on. And if the voltage does not reach the output device, it will turn off. No matter how you think of the ladder logic diagram, the goal is the same. You need to understand how to make an output turn on or turn off depending on the state of field devices. The commands in a PLC ladder logic diagram are shapes that represent a command. In order to control the outputs, you will need to understand what each of the commands is doing. The first three commands that you will need to learn are the examine if closed command, the examine if open command, and the output energized command. The easiest command to learn is the examine if closed. The XIC is an input command. The first thing you need to understand is the field device is not physically connected to the XIC. Instead, the XIC is monitoring the field device and makes decisions based on what it observes. A normally open, momentary switch is being monitored by the XIC command in this explanation. If the switch is open, the XIC will block the input and automatically output a logical 0 or 0 volts. When the switch is closed, the XIC will pass the input to the output. If there is a logical 1 on the input, there will be a logical 1 on the output. And if there is a logical 0 on the input, then there will be a logical 0 on the output. This is where some beginners make a mistake. When the button is pressed, it does not output a 1 or a positive voltage. It just passes exactly what is on the XIC input to the XIC output. The next command to learn is the XIO command, where XIO stands for examine if open. The XIO is also an input command, and just like the XIC, the XIO command will monitor a field device and make decisions based on what it observes. The XIO is easy to understand because it works just like an XIC, except the actions are reversed. The previously discussed XIC command will output a 0 when the switch is open. But when the switch is open, the XIO will pass data. And the previously discussed XIC command will pass the data when the switch is closed. But the XIO will block the data and output a 0 when the switch is closed. So, as stated before, the XIC and XIO work the same way, but the actions they perform are reversed. The third command to learn is the OTE command, where OTE stands for Output Energized, and as the name suggests, this is an output command. Just like all of the ladder logic commands, the OTE is not connected directly to the field device. Instead, it sends a command to the output card, and the output card will turn the field device on or off. The OTE works exactly as you expect it to. If it receives a logical 0 or 0 volts, then the output is turned off. And if it receives a logical 1 or a positive voltage, then the output is turned on. These three commands are summarized here. You may want to pause the video, take a few minutes to review them. It is crucial that you understand these commands because they are the basis of all of your PLC programs. To demonstrate the basics of a PLC program, we will look at this example. The rungs in a ladder logic diagram are numbered from top to bottom, starting at 0. So, the first rung is 0, and the second rung is 1. The last rung is always the end rung, and you can just ignore it. For now, we will just focus on the top rung. The rungs are evaluated from left to right, where the inputs are on the left and the outputs are on the right. In this example, the input is an XIC command, and it is monitoring the momentary switch connected to the input card. The left side of the XIC is tied to the left rail. This rail is always logical 1 or positive voltage, however you want to think of it. The OTE command is controlling a red lamp that is connected to the output card. When demonstrating how a ladder logic diagram is working, a green bar is often used to represent the positive voltage or logical 1. This keeps the diagram neat and easy to understand. At this point, switch 1 is not pressed, so the XIC output is logical 0 or 0 volts. This is fed to the OTE command. Because it is receiving a 0, it will turn off red lamp 1. So when the switch is unpressed, the lamp is off. When the momentary switch is pressed, the XIC command will pass the logical 1 on the left side of the command to the right side of the command. The logical 1 is fed to the OTE command, and because it is receiving a 1, it will turn on red lamp 1. So when the switch is pressed, the lamp will come on. Let's expand this program and add a second rung. This newly added second rung has an XIO command, and it is monitoring the OTE that is controlling red lamp 1. This is allowed. An input can look at any device connected to the input card, and it can look at any OTE command. This newly added rung also has an OTE command that is controlling a green lamp. The left side of the XIC and the left side of the XIO are connected to the left rail, so both commands have a positive voltage or logical 1 entering them. Now let's step through this PLC program, one rung at a time, starting at rung 0. Switch 1 is not pressed, so the XIC has a logical 0 or 0 volts on its output. This value is being sent to the OTE controlling the red lamp, and because this is a 0, the red lamp is off. On rung 1, the XIO command is receiving a logical 0 from the OTE. On rung 0, the XIO will pass the 1 on the left side of the command to the right side of the command. The OTE on rung 1 will receive a logical 1, and then send the command to the output card to turn on the green lamp. Now let's see what happens when the switch is pressed. When the momentary switch is pressed, the XIC command will pass the logical 1 on the left side of the command to the right side of the command. The logical 1 is fed to the OTE command, and because it is receiving a 1, it will turn on red lamp 1. The XIO command on rung 1 is now receiving a logical 1 from the line above it. And when an XIO sees a 1, it will output a 0. This 0 will be sent to the OTE controlling the green lamp, and because it receives a 0, it will turn off the green lamp. When switch 1 is released, it will go back to the previous state and the green lamp will be on and the red lamp will be off. In the next video, example 1 will be coded using the RS Logix 5000 software. The ladder logic will then be downloaded into a physical PLC controller and tested. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This will help introduce these videos to other students who might be struggling in their PLC class.